Okay, I agreed that I would put out how to solve exam chapter 4, and so I hope I'm recording right now. And let's see, this one is asking me to estimate from 0 to 9 this integral, and it's giving me this using 3 sub intervals with left endpoints. And so let's first find out what our delta x is. It's b minus a over n, which is 9 minus 0 over n, which is 3, so it's 3. And we're starting here at 0. We're going to go over 3, 1, 2, 3, so we're going to go here. And it told us to use the left endpoint, so I'm drawing out my rectangle and then I'll find my area. So this is the base of my rectangle right there. That's the base of my rectangle, and I want to use the height to be the left endpoint. So between 0 and 3 over here, the left endpoint is here at, must be 3, right? So we have this. So this is our approximating rectangle from 0 to 3. Okay, and then we're going to go from 3 to 6, so 4, 5, 6. And we're going to use the left. So this is the left endpoint, and this is our approximating rectangle here. And then from 6 to 9, 7, 8, 9. And I'm going to use the left, which is here. Okay, so the approximation for our integral I'm going to use squiggly equals for approximation, is going to be this rectangle right here, which is 9, right? You can count it if you like. You can also say it's 3 by 3, however you want to do it. So the width times the height, 3 by 3, whereas this one is 3 by negative 1, and this one is 3 by negative 2. And I think coincidentally, I think this is approximately 0, right? Is our approximation. So we did a lovely job on that one. Did I do everything they asked me to do? I think I did. Okay, here they say the graph of G consists of 2 straight lines and a semicircle. Use it to evaluate the integral, and they said from 0 to 20. And so they told us this was a semicircle. So I was looking at the scale here, and this is 20. And I see that after 2 is 10. Could this be 10 here? And after 2, oh yeah, the scale's all perfect, right? It's by 5s, counting by 5s. So I don't know that I needed to label all of that, but I started labeling and then couldn't stop myself. Okay, so this integral to 20, right, is here, and then it's going to be in here. So we're going to have to find the area of a triangle and the area of this semicircle, and so this is the triangle is half the base, which is 10, times the height, which is 20. So that's 5 times 20 is 100. So that's this right here, 100. And then the semicircle, well, the area of a circle is pi r squared, and this is 1/4 of a circle. So the area over 4 of a circle, which is pi r squared over 4, right? With a radius on this circle of 10, because it goes from 10 to 20. That's the radius, and from 20 to 30. So the radius is 10. So this is pi times 10 squared over 4, which is 100 over 4, which is 25. So 25 pi. So remember that the integral, so this area right here is 25 pi. And remember that the integral would count the area above the curve as positive and the area below the curve as negative. That's what the integral would count this as. So this is going to be 100 minus 25 pi. For A. And then for B, well, the bounds are backwards, so you need to write them in order. So this would be negative 10. Remember, you do the negative from 10 to 35 of g of x dx. Now that I've done that, I'm going from 10 to 35. So I have that semicircle, right? So I'm having negative of, and that the semicircle, which is the area of the circle over 2, right? And that should be negative, right? So negative of the area of the circle, so wherever I find that is. Well, I already know what it is, right? It's 25 pi plus 25 pi, which is 50 pi. So this is negative of negative 50 pi. So that's the, right? Because each area, each piece, because I already found that. So I'm just gonna go with it. Is that okay? And then this is above the x-axis, so plus, and then that little triangle. Now remember, this little triangle, half the base times the height. The base is 5, because it's going here from 30 to 35, so the base is 5, and the height is also 5. So this is 25 over 2, and it's positive, so plus 25 over 2. And I don't know, I decided to distribute the negative, so this is 50 pi minus 25 over 2. I'm going to make that a little neater. Okay, so we did a lovely job on that. Then here, they're asking me to find the antiderivative, and I can see, oh, the pieces are all nice pieces, right? This is nice. I would write it as x to the 1/4, and then it's power rule, unpower rule, power rule. I've memorized that the integral of sine of ax dx is equal to negative cosine of ax over a, right, plus c, and I'm going to put a plus c at the end of it, and my a here is 3, and so I'm going to go with that. I would write this so that I could use power rule, and then this is all perfect. So I'm just going to kind of make this so that I can use the power rule. So this is x to the 1/4 minus 2/3 x to the 2nd, and then minus sine of 3x. So all this is perfect. And then this one I have to fix up. So this is plus 1/3, and then this is x to the negative 4, right? And I don't want to put the 3 out of the denominator, plus 8 dx. So that when I take the antiderivative, you add 1, so 1/4 plus 1 is 5/4, so x to the 5/4, divide by the same darn thing. So when you divide by 5/4, that's the same as multiplying by 4/5, minus the 2/3, hold still, add 1, x to the 3rd, divide by the same darn thing. And here, negative of a negative is positive cosine of 3x over 3. And no, the 3's don't cancel. Plus 1/3 x to the negative 5, divide by, oh, add 1, sorry, that's negative 3. I don't know, I was subtracting 1, I got crazy. So negative 3, add 1, divide by the same darn thing, plus 8x plus c. So other than making it look just a tiny bit nicer in my little spot with my fat pencil, I think I'm going to be able to do it. So minus 2/9 x to the 3rd plus, you could write this as 1/3 cosine 3x if you wanted, that'd be great, it doesn't matter, minus 1/9. I'm going to put the x to the 3rd down here like that because that's how it was, right? Plus 8x plus c. So we did a lovely job on that, piece by piece. This one, they're asking me to find the antiderivative, and it is not one of my friends. Like, these were each one some friend that I have. This one's not one of my friends. It doesn't look like it's a trig substitution. And I can't divide it, so it must be a u substitution because that's basically what I know. So I'm thinking u substitution. I'm going to let u be the inside function, which is x to the third minus 5x. du equals then 3x to the second, and that's like good because that's gonna gobble up that x to the second. So this is my plan. So I'm going to have here x to the second, and then I'm going to plug in there u. So this is u to the fourth. And then I like to write this as du over 3x squared equals dx. And then substitute it in for dx, du over 3x squared. You get where you don't have to do that. I don't have to do that myself, but when I'm showing someone how to do it, that's what I usually do. And so the x squares cancel out. And so remember, this is in the denominator, and it's a constant, so I can bring it in the front. So when I bring it in the front, well, what does it have in the numerator if that's all I have to bring in the front? Well, a 1, right? So placeholder 1. And then I would want to write this as u to the negative 4 du so that I can find the antiderivative. Your choice whether or not you just leave the 3 in there, that's okay. Add 1. So when you add 1, that's negative 3, divide by the same darn thing. It's kind of similar to that one, isn't it? And so I get the 1/3 here in the front. And so I'm going to have 1 negative 1/9 u. I'm going to put this u to the third down here plus c. And that's really not my answer because no one cares about u. They only care about x, right? So this is really, I know that's a bad joke. Everybody cares about you. Sorry, I didn't mean to hurt your feelings. X to the third minus 5 raised to the third, and then plus c. Okay. Then here they're asking us to evaluate the integral, and here they had told us they were indefinite integrals, which means they don't have bounds and you'll need plus c. Here they're asking us to evaluate the integral, and I can see that it's a definite integral. It has bounds. I can divide this, right? So I'm going to divide it in order to find the integral. So from 1 to 9, and so 2 divided by, right, this is 2 over the square root of x plus x squared over the square root of x. So that's what my little head is thinking. So this is 2x to the negative half plus, and then 2 take away half is 1.5, x to the 3 halves dx. So you add 1 and you divide by the same darn thing. So the 2 holds still. I add 1 to here, I get half. I divide by half, which is the same as multiplying by the reciprocal 2, plus I add 1, that's 5 halves. I divide by the same darn thing, 5 halves, which is the same as multiplying by 2/5, from 1 to 9. And now I'm using the Fundamental Theorem of Calculus Part 2, so this is going to be 4 times the square root of 9, right, that's the square root, plus 2/5, and then 9 raised to the 5 halves, this, minus, and then 4, and then the square root of 1, plus 2/5 times 1 to the 5 halves. So I'm going to figure out what this is, and actually that's going to be pretty nice, right? And so because it's asking me to take some square roots there, but my square roots are perfect squares, so it could have been worse, much worse, much worse, but it was pretty kind. They have a variety in your book of ones that are kind and ones that are worse, right, to practice. So this is 546 over 5 minus, I just put it in my calculator, and then this is 4 plus, did I make a sign error, plus 2/5, which is 22 over 5. So 546 minus 22 all over 5. So I did a lovely job on that one. Fundamental Theorem of Calculus Part 2. And so here's some more Fundamental Theorem of Calculus Part 2. This antiderivative, focus my friend, this antiderivative right here, I noticed it's got trig in it, and I was thinking, okay, trig, And 1 over cosine, I know that 1 over cosine of x is equal to secant of x. And so I cannot take the antiderivative of this, but I can do this trig identity, right? And so in fact I have squared, so this is going to be secant squared. And then it's like, oh, now it's a friend, right? Because the integral of the secant squared, that's one of my friends. That's equal to tangent of x from pi over 4 to pi over 3. So this becomes the tangent. So this had a little bit of a trig substitution in it. Tangent of pi over 3 minus tangent of pi over 4. And I know that the tangent of pi over 4 is 1. And I know that the tangent of pi over 3 is, I think it's the square root of 3. But I'm going to make sure on my calculator. So my calculator is, of course, in degrees. Who's been using my calculator? That they would put it in degrees. That's just rude. That anyone would put my calculator in degrees and leave it that way. So tangent, but you always check, is my calculator in degrees, of pi over 3. And I thought it was the square root of 3 from my memory, and it is. So the square root of 3 minus 1 is my answer. And then this one here, I'm looking at it, and I don't want to multiply that together 6 times. I mean, that would take all day. It would take certainly a lot of time, and then multiply by x. If I did that, it would give me the right answer. So I was thinking instead of using a u substitution in order to, because I can't multiply that, right? It doesn't seem like trig substitution would be that good. Not trig, right? So u equals x minus 1, the inside function, and du equals dx. And so when I go to fit this in here, so this is part of my plan, the lower bound is x equals 1, and so u equals, and then you put in what x is 1 minus 1, right? 1 minus 1, so u equals 0. And for the upper bound we have 3, and so we get u equals 3 minus 1, which is 2. So as we transfer this thing up, we get the bounds go from 0 to 2. We get x here that I haven't gotten rid of. We get u to the 6, so times u to the 6, and then dx equals du. And usually I get rid of the x, but this time I didn't get rid of the x, and so I'm like, oh, I didn't get rid of the x. And so that's the only thing that I have to get rid of. But here is our hint of how to get rid of that x that we weren't able to get rid of, is that we know that u plus 1 equals x. So I'm going to use that. So I'm going to replace right here for x, u plus 1. So this is the integral of 0 to 2 of u plus 1, u to the 6 du. And now this is something I can multiply together. So this is u to the 7th plus u to the 6th, the integral from 0 to 2. I almost forgot my integral, du. And then I can take the antiderivative of this, just power rule, right? Add 1 and divide by the same darn thing. Add 1 and divide by the same darn thing from 0 to 2, right? I'm not going to go back to x, so I'm just go ahead and using my bounds for u. So this is going to be u to the 8th over 8 plus u to the 7th over 7 minus, and then 0 to the 8th over 8, right? And plus 0 to the 7th over 7. 0 is so nice because that's just gone. So all I have to do is worry about this. So 2 to the 8th over 8 plus 2 raised to the 7th over 7, and I got 352 over 7 when I did that. Okay, so we did a lovely job on that. So here is an initial value problem. It says it's an initial value problem. They say that I have f prime equals 1 plus 3. They want me to find f. So I can find the antiderivative of this and this. When I find the antiderivative of this, I get f of x, which is nice. The antiderivative of 1 is x. And the antiderivative of sine, remember, is cosine. So this is the 3 holds still. And sine, the integral of sine of x equals negative cosine of x. Do you guys agree? So I really am going to have to change the sign right here, right? Negative 3 cosine of x plus c. And in order to help me find my c, they said when x is 0, f of x is 25. So we're going to be putting in here 0 for f of x, right? So we're going to put in 0, f of 0. And that equals 0 minus, so 0 minus 3 times cosine of 0 plus c equals 25. Is that okay? And remember, cosine of 0 is 1. So this is minus 3 plus c equals 25. And so c equals, adding 3, 28. So my f equals x minus 3 cosine of x plus 28. And then we can go on to the next one. On number 9 here, and number 9a and 9b, they're asking me to find f prime. And I notice, oh, they're asking me, f is defined to be an integral. So they're asking me to do the fundamental theorem, right, of calculus part 1 is what they're asking me to do. So you have to make sure that you have a constant here and a variable of x here, which you do. And then it's just a matter of doing their little undo, right? They say all you have to do is plug that in. And so this would be 5 minus x raised to the third. So that would be the antiderivative, that would be the derivative there. On this one, because this is not just simply x, I do have a constant down here though, I do the plug in, but I have to do the chain rule, right? So I have to, so this is secant of x to the third, but I have to do the chain rule. I have to multiply by the derivative, right? The derivative of x to the third. So d dx of x to the third, which is 3x to the second. And then just a little rearrange just to make it look nicer and make me feel happier, because people put monomials like 3x to the second first before their trig. So there I have this, and there I have this. So fundamental theorem of calculus part 1, not hard as long as you know what to do there, that the derivative and the antiderivative are undo one another. And then the last but not least problem, they're asking me to, they're giving me the velocity function, and they're asking me to find the displacement and the distance traveled by the particle on the given integral. And I know the displacement is given by, from 2 to 4, the antiderivative of the velocity, which is t squared minus 2t minus 3 dt. Right, so that's what the displacement is by definition. And so I'm going to just find that. And so this is t to the third over 3. I can find the antiderivative, minus 2t to the second over 2 minus 3t. I'm going to evaluate that from 2 to 4. So those are go away. And I'm going to have 4 to the third over 3 minus 4 to the second minus 3 times 4, right, minus, and then 2 to the third over 3 minus 2 to the, how did that go there? Trying to make a mistake. I was just trying to test myself. 2 to the second minus 3 times 2. Okay, and displacement could be positive, it could be negative, I don't know. I can kind of look at this picture from 2 to 4 that they've given me. So sweet of them. And this area here above does look bigger than the area below, so I think it is going to be positive, but it doesn't look that big, right? That area. When you take this and you subtract that, it doesn't look that big. I don't know, size is relative. Okay, and the relative of your sizes, how does that go? So I'm putting this in, minus 16 in my calculator, minus 12. So here I got minus 20 over 3
and then minus, and then in here I'm going to get 8 over 3 minus 4 minus 6. So I'm going to get minus of negative 22 over 3. So when the dust clears here, I get negative 20 over 3 plus 22 over 3, which is 2/3. And there's probably got units on here. They say the velocity, I'm looking, is meters per second. So that would mean that the displacement would be in meters. Okay. Then the distance, so they asked me for displacement, so that's 2/3, I'm writing it down here, 2/3 meters, right? And they asked me for the distance as well. So the distance is equal to, from 2 to 4, the absolute value of the velocity. So this is my absolute value symbol, t squared minus 2t minus 3 dt. And they've given me a lovely graph here. And I can see that where this crosses the axis, where the parabola crosses the x-axis here at 0, is at 3. And that's nice. I need to know that. So I got choices of how I can do this. If you wanted to, you could break it apart and you can say, so choices, choices, choices. You can go from 2 to 3 of t squared minus 2t minus 3. And you want the negative of that because it's below the x-axis and we want it to be positive, right? So it's below here. So I'm going to hit it with a negative. When I take it outside the absolute value, I get the negative of that. So put the negative here or distribute it through, your choice. I don't care. It doesn't matter. And then I'm going to add that with, and then the integral from 3 to 4. Now this is above here of t squared minus 2t minus 3 dt. There was a dt here too. Okay, and so that will give it to you, friends. And so all you have to do is, plus here, all you have to do is do this and you'll get it. So you'll find this is negative and you'll hit it with a negative, that'll make it positive. And so that's a way of going, if you like. And so wonderful if that's what you would like to do. So I just do that. There's other ways of doing it. And I pretty much don't care. I mean, it's your decision. I'm with you. This is t squared minus 3t from 2 to 3, right? And plus, and then same darn thing. 3 here minus t squared minus 3t. I want to make sure that I have that same thing here because I was talking on the second time that I did it and don't want to make a mistake. So, and then I'll hit it with a negative after I get it. So this is negative of, and then this is 3 to the third over 3 minus 3 to the second minus 3 times 3 minus, and then, oh, I didn't find it, so I don't, no, I did find it, didn't I? When you put in 2 into here, I found it was negative 22 over 3. So I'm going to just use it. Negative 22 over 3 plus, and then we're going to have here, when we put in 4, now I found when I put in 4, it was negative 20 over 3, so I'm going to use it. Minus, and then when I put in 3, well, I didn't find it yet, but I will, and then it's the same for both of those. So that's 27 over 3 minus 9 minus 9. So this right here is minus 9. So this right here is minus 9, right? Because they're both plugging in 3. So this is going to be in here negative 9 plus 22 over 3. So this is negative of negative 5/3 plus, and then whatever this is, which is negative 20 over 3 plus 9, 7/3. So what I kind of just found is that this area right here below this axis is 5/3. and this area here, which the integral counts as negative, is 7/3. So that when you do it, you got positive here, 7/3, minus 5/3 is 2/3, right? So that's great. And so that would have been a way of doing it to begin with, is to find each of those pieces, right? And then when I add these together, though, I get 12/3, which is 5 plus 7, right? Which is 4. So this is 4. When you add these together, you get 4. So that is the distance, 4 meters. And that is the exam. That's all there is, my friends.